Wasabi, guys, we are coming back to this deadly integral because this integral is common and reoccurring in a lot of integration bees, especially at the intermediate and advanced levels, so we need to know how to survive this integral. Okay, so the reason why I'm coming back is because I have 3 methods to show you. So I'm going to give you 3 options for you to study how to speed solve this integral. Okay, so option 1, which is what I'm about to show you right now, is a suggested method from CBMiami, and I'm going to go ahead and so pretty much in this option, we're going to let u equal square root of x, right? So of course, we have 2u and u squared plus u, and then we complete the square, right? U plus 1/2 squared minus 1/4. What we're going to do is we're going to let u equal let w equal u plus 1/2. Then u is equal to w minus 1/2. And so what we're going to get is we have 1/2, 3/2, and then here from 2u is going to equal to 2w minus 1. So we have 2w minus 1 of w squared minus 1/4. Okay? Now, here, the main part of this method is we're going to do trig substitution. So let w equal 1/2 of secant theta. dw is equal to 1/2 of secant theta tangent theta d theta. Okay? So now, for the bounds, we have, 3/2? So 3/2, we have like inverse secant of 3. And then for 1/2, we have 1 equals secant theta, which is 0 for theta. Okay? 2w minus 1 is secant theta minus 1. Okay? Here, we have 1/2. This comes out to 1/2 of tangent theta. And then we have 1/2 of secant theta tangent theta d theta. Okay? So now what we have in total, so we have 1/4 from 0 to a. We're going to call this a because I'm tired of rewriting it. And then we have, let's see, secant theta squared minus secant theta. And then we have tangent square d theta. So what we have, we can go ahead and split this. We have secant square theta tangent theta. And then we have minus, and then secant theta, we can turn this into secant square minus 1. So now we have secant cubed theta minus, so that'll be plus secant theta. And this is what we have. Okay? And then here you integrate this, and then you solve these because you know the formula for secant cube. So if you're more comfortable dealing with secant theta and going into this route, then this is the method that you should study and memorize. Okay? So here you just go into 1/4. This is 1/3 of tangent cube theta. This is, here we know this, we're going to have 1/2 of secant theta tangent theta, and then 1/2 minus 1/2 of ln. But then we have this, so 1 minus 1/2, we get a positive 1/2 of ln secant theta plus tangent theta. Okay? From 0 to a. And notice when you plug in 0, they're all going to equal to 0 because of the tangent and the ln. Yeah, pretty much because of tangent theta. Okay, now for a, plugging in a, we know that secant, we can put it at the side and label it as reference, so that's, you don't have to like try to mentally solve it. So secant a is, well, a is equal to inverse secant of 3, so secant a is going to equal to 3, and tangent a is going to equal, well, tangent a is going to be, I'm sorry, that's not right. Pretty much tangent of arcsecant, okay, is going to equal to x squared minus 1, because if you plug in x as secant theta, it's going to come out as a tangent theta, right? So it's going to be, let's see, so we'll get 3 squared minus 1, which is 8, so square root of 8. Okay. And then you just, that's pretty much all you have. So you can just plug it in. Instead of, if you know, it could be very tiresome to like write this all the time sometimes, even though it's effective. It can be tiring, especially when it's like long like this. But that's only, but you see, with, it's not that complicated. You know, if it was something like, like 2 inverse, then yeah, we could just leave it. You know, but you can leave it, or you can put a label as reference and then be like, oh, okay, so this is, now the whole answer is like 8 square root of 8 over 3 minus 1/2 of what, 3 root 8? 3 root 8 plus 1/2 of ln of 3 plus root 8. And you're done, right? And then you just go like that, and you're done. Okay? Alright. So that's that. This is option 1. This is the going the route of secant cube. So if you memorized secant cube of that answer, then this would be the fastest route. So the main points to memorize is when we go from here, we go from here to completing the square. So you go here to here, and then the idea is to let w equal u plus 1/2. So that it'll look like this. So you're going from here to here to here, and then trig sub using secant theta. And that's going to give us here to here. Do not forget that 1/4, because you are trig subbing with a constant. Okay, so we got 1/4 of secant square theta minus secant theta, all that times tangent square. And then pretty much you distribute and turn that tan square for this term, turn that tangent square in terms of secant cube and secant theta. Okay? And that will just lead you to here, to your answer. Okay? Alright, don't forget that a is equal to inverse secant of 3. So this is the route that you would memorize if you're more comfortable with secant theta, handling with secants. Okay? Alright, so that's option 1. Okay, go ahead and memorize that process, and then you start to get a feel of like, okay, I know what to do next. And if you do this a lot, if you do this whole process a lot, you'll just end up memorizing, oh, this integral equals up to this integral here. Okay, if you do this a lot, then you get the feeling of, oh, okay, I speed solved this method so many times. This integral is equal, and then you just dive straight into, oh, this is 1/4 of secant square minus secant theta. If not, then you can dive in right into here. Okay, as like your second step. All right. But take your time first, though. Get used to this method first, and then as it becomes very repetitive, you can start skipping steps. All right, so that's option 1. What is option 2? So option 2. So if you're not much of a fan of trig substitution, or you're not very much of a mastery in trigonometry, what you can do is you can do the second option. If you're more of a graphing, visualizing type of guy, or an algebra type of guy, we're gonna use inverse jailbreak. Very satisfying. It's probably the most satisfying method for me, but I also at the same time I'm not a fan of it, because there are some traps that you do have to be careful. This one is kind of trappy, so I would probably prefer this method for like advanced speed solvers. Okay, so yes, we're gonna do inverse jailbreak. So this is the second option. So the second option here, thank you, Ninad, for warning me about the trap. I'll show you what I mean by the trap. So when we take an inverse, okay, this is now y squared, and then minus x equal to square root of x, and we're going to square it again. Okay, I know this sounds nasty, but just trust me on this. Okay, so x squared, then we have minus 2x y squared plus y fourth equal to x. And so now what we have is x squared minus 2y squared plus 1 of x plus y fourth. So what is x? So our inverse is 2y squared plus 1 plus or minus, and then the square b squared, which is 4y4 plus 4y plus 1 minus 4ac 4y4. So these two cancels out. That should be 4y squared, I'm sorry. All over 2. Okay, so here's the trap. Okay, we do have a definite integral. So I have a question for you. Is it negative or is it positive? So a lot of the times during the inverse jailbreak training or infinite functions, a lot of the times we go with a positive route because of the interval, right? Well, unfortunately, we are technically inverse jailbreaking. We are finding the inverse. So it doesn't quite work with it's not about the intervals that we have. No. Okay, it's about the inverse. It's the inverse. So, unfortunately, this is the trap. If you think it was positive, you would be eliminated. The actual inverse is 2y squared plus 1 minus 4y squared plus 1 over 2. This is the actual inverse to this function specifically. The best way I can describe it, explain why. Again, first of all, it's not because of the interval, because we are taking the inverse. We're not doing any u sub. We're not, it's not this function. Okay, it's the inverse of this function. Okay, so again, just to reiterate, we are choosing negative, and it's not because of the interval of this integral. Okay, usually a lot of the infinite functions we deal with, it is because of the interval, because we are integrating the infinite function. But this is the inverse. This is the inverse function, so this is completely different. Okay, now again, going back, the reason why it's hard to explain why it's negative, but the best way I can show you why it's negative is by a graph. Now, obviously, we cannot imagine what the graph of this looks like, because who the hell memorizes the graph of this? Okay, but to show you in Desmos, you can see that this is the function for, the red one here. This is the function for the square root of x plus square root of x, right? Now you can see that this blue one is the complete inverse. But this blue function here, this is negative. Okay? what happens if it was positive? If it was a positive, it would look like this, and it would not be the inverse. Okay, this would be incorrect. As you can see, it does not follow the inverse, and the reason why we end up with two solutions like this is because this function is not injective. It is not a one-to-one function. So that's why we get things like this. So unfortunately, the minus version is the correct inverse function. Okay? So be extremely careful when dealing with inverse jailbreak. You have to be extremely careful. All right? This is our actual inverse function, the minus root. So if our f is 0 to 1, then our bounds for the inverse function is plug in 1, we get square root of 2, and plug in 0 is just 0. So this is going to equal to square root of 2. So our integral for this is square root of 2 minus from 0 to root 2, and then we have x squared plus 1/2 minus 1/2 of 4x squared plus 1. But what you can also do is you could take that half out by factoring the 4 out. And so you'll technically just have this. So this would be your integral. Okay. So if you are more comfortable with algebra, like extreme algebra, this is the route to go. Or in fact, you can literally, if you do this so many times, you can go from here and skip this whole step and go dive into this integral instead. Okay. The only issue, well, it's not an issue. The only annoying part is you have to remember this is minus. Okay. I know it's very unusual, but this is minus. And you have to deal with this integral as well, which kind of follows the same reason for the option 1, right? The secant cube, right? So let x equal 1/2 of tangent theta. So if you let x equal 1/2 of tangent theta, then you'll be left with like 1/4 of like secant cube theta. And if you're comfortable with this, then by all means do it. Okay, no, there's no wasting time with this integral, because this integral is gonna kill all of us if we do not find a method to speed solve this. Okay, so if you're more comfortable with secant cube, because we know the formula for this, then this is the route to go. Okay, so if you're more comfortable with trig and dealing with secants, use option 1. If you're more comfortable with algebra, make sure that you do not get trapped. Okay, do not get trapped with that, and instead use inverse jailbreak. Use option 2. Okay, and then you should be good to go. In my opinion, I think this would be, now I think about it, going here, if you do this so many times and then you just memorize, all right, I know that this is going to equal to this straight up, this would be the fastest, the most comfortable method, right? It's algebraic and it's just only secant cube. And now the third option, which is the route that kind of figured out. It's the same method as our last video where we use hyperbolic. So here was my method. Okay. So, of course, we let u equal square root of x, which results to this, right? Okay. And then I decided, you know what? I'm going to kind of cheat a little bit. So what I did is I turn this into u plus 1. And the reason why I want this to be u plus 1 is because, well, it's just u substitution. Let w equal u squared plus u, and you're done. That's it. So I want this to be u plus 1. But then I'm left with this. Okay, so now my complete answer is like 2/3 of like u squared plus u 3/2 0 is just 0. So this is just plug in 1, I get like what, square root of 8, 2 square root of 8, 4 root 2 over 3. So this is 4 root 2 over 3. Okay. So I'm going to put parentheses here. And then minus here, and then we complete this complete the square, right? And it's the same exact type of method from option 1, where we complete the square and let u or w equal to u plus 1/2. So now we have w squared minus 1/2. Okay, because we let w equal to u plus 1/2. Alright, so now I don't have to deal with the w at the front. Now here I can just go ahead and dive into hyperbolic substitution. So this is cos theta, right? And now we have dw equal 1/2 of sinh theta. And so I memorized, okay, so this is 4 root 2 over 3 minus the integral. We're going to have 1/2 and then a half here. So it's going to be 1/4, 1/2. Oh, I'm sorry. This is the balance changed because we hyperbolic sub. So half here, theta is going to equal to 0. 3/2 here, we're going to get inverse cos of 3, which I'm going to label as A. And the rest comes out as sinh square theta, d theta. Now, the way I kind of remembered is because I did this so many times, right? If we square sinh, right, we get 1/4 of e2x plus e to the negative 2x minus 2. Pretty much I end up with 2 cos 2x minus 2. And this is equal to 1/2 of cos 2x minus 1. Okay, very similar. So, very similar to the trig identity, but you have to be careful it's flipped. Okay? So, because of that, because I did that so many times, I just kind of memorized the identity. Oh, this goes to 1/4 of, consider it A. Oh, I'm sorry. And then the half goes into here, and then cos 2 theta minus 1 d theta. And so I just straight up dive into, okay, so now this is just minus 1/8 of, I know plugging in 0 is everything's gonna equal to 0, so I didn't want to waste any time. I just instantly wrote like this. And then my answer, okay, so then my answer is 4 root 2 over 3 sinh of 2 cos over 16 plus 1/8 of inverse cos of 3. And this was my answer. Okay? And then because I did this so many times, I went from here, and I was like, okay, I memorized, you know, I've repetitively done this so many times, I'm going to skip steps. This is equal to this. Or I'm sorry, 4 root 2 over 3 minus this. That was that, or this sinh square, if this helps me memorize. I think this is what helps me memorize a lot better, is the sinh square. Okay? So this was my method. I hear, and then I did this so many times, I'm like, you know what, I'm gonna skip steps. This is equal to this, because I remembered. So you pretty much memorize that this integral is equal to this expression here. And then you go ahead and integrate. Okay? So that was my method. And yeah, so if you don't mind hyperbolic, right? If you actually don't mind hyperbolic, then you can go ahead and dive into this. Honestly, out of all, I think the most efficient, in my opinion, would be the second option, because it is less steps if you think about it, but it is trappier. So that's the only thing you have to be very careful, is that it is trappier if you don't know what you're doing. So don't forget the negative, and understand that your balance changed in inverse jailbreak, and then you're good to go. Okay? But other than that, the second option is pretty fast if you're very good with algebra. But we have, the other options are also just as fast if you're more comfortable with dealing with secant thetas or secants. Use option 1. If you're more comfortable with algebra or have very good graphing visualization, option 2. And then if you're like me, who is lazy and would just use hyperbolic trig, and you don't mind using hyperbolic trig, especially identities like this, then stick with me using option 3. Okay, so those are the 3 methods that could potentially help survive this deadly integral. Okay, all right, I hope that was helpful. Thank you to you guys, the comments, CBMiami and Ninad for the suggested methods. And yeah, I hope this helps. I'll see you guys in the next video.